Lesson 15. Writing linear expressions. Lesson objectives. Students will be able to rewrite expressions in different forms to better understand relationships within contexts. Students will be able to incorporate expressions representing length and width into formulas for perimeter and area of triangles and rectangles. Those are the content objectives. Let's look now at the language objectives. Remember, you should be able to say, I can. So by the end of the lesson, you should be able to say, I can read to understand how to identify and evaluate equivalent expressions. I can describe 3 equivalent expressions using the terms length, width, and equivalent expressions. I can write complete sentences to explain 2 ways of finding the sale price of an item. I can describe how to find the sale price of an item to a partner or small group. I can read word problems that require students to follow a set of instructions. The prerequisite skills: understand the concept of equivalent expressions, simplify expressions, and write expressions to represent problem situations. Now let's look at the lesson vocabulary. Equivalent expressions, expressions that have the same value for every possible value of the variable. And we will break that down. Review the following terms: adjacent, remember, next to each other, and dimension, length in one direction. A figure may have 1, 2, or 3 dimensions. And let's look now at the learning progression. In grade 6, students learn to represent situations with expressions and equations. Early in grade 7, students learn to represent situations mathematically, perform necessary calculations, and understand the results in terms of the original situation. In this lesson, students will learn that while equivalent expressions describe the same situation, different expressions can give different perspectives and might be more useful for certain purposes. For example, if an item costs X dollars, we don't know how much, the sale price after a 30% discount could be given by either X minus 0.3X or 0.7X. Remember, 0.3X, 0.3 is the same as 30%. And the reason they're saying 0.7X is because we always deal with 100%. Okay? So you're either subtracting the 30% or you're paying the 70%, which is 0.7X. One expression describes the sale price as a discount subtracted from the original price. The other describes the sale price as a percentage of the original. Both methods are equally valid. And then moving forward, in grade 8, students will build on this skill and solve linear equations with rational coefficients. After grade 8, students will work with situations involving functions and integer exponents. Let's use what we know. You learned how different expressions can represent the same situation. Take a look at this problem. This swimming pool was designed so that sections of the pool can be used for different activities. I want you to think about a swimming pool that you've seen that before. YMCA, I think some YMCAs have them. Okay, some high schools have them. Okay. The dimensions are given in meters. Write 3 different expressions to represent the total area of the water surface of the pool. You got the lap swimmers here, the water therapy, the kids area, and then the swim lessons. Okay? Look at this length and width. Okay? Here's the model again, and we're going to use the math we already know to solve this problem. So I want you to solve A, B, and C to the best of your capabilities, and then we'll go over it. I would pause this video. I'm going to read them for you, but I will pause this video after, solve the problems, and then check your answers. A, you can think about the total area of the surface of the pool as the sum of the areas of the swimming sections and the other sections. Write an expression that represents this way of thinking about the total area of the surface. Think about that. Okay, and look how they drew it. Area of the swimming sections plus the area of the other sections. You can think about the total area of the surface, such as 25 times 8 plus 7 times 8 plus 25x plus 7x. I want you to think about that. You should look at the picture looking at that, see if it makes sense. Draw and label a picture that shows this way of thinking about the total area. And then question C. You can think about the total area of the surface as 25 plus 7 times 8 plus x. Explain the thinking behind this expression. So again, pause this video, solve them, then unpause, and we will review your answers. Well, let's see what you got for A. If you got 8 plus x times 25 plus 8 plus x times 7, you are correct. Remember how to find area of a rectangle, right? Base times height, or you can say length times width. So there it is, length times width. The width is 8 plus x, we put it in parentheses, times 25, and then you have same thing here. 8 plus x times 7, and then obviously you're adding both of them together. Let's look at question B. Okay. As you can see, they separated the 4 rectangles. If we go back, they got the lap swimmers here, 25 by 8. Right? Let's look at this. Lap swimmers, 25 by 8. Everybody see that? Okay. Then they got the water therapy, 7 by 8. Let's look at and do a different color for the water therapy. 7, right? 7 by 8. Okay. And then they got the swim lessons, 25 by x. Let's look at that. Here's a different color again. Swim lessons, 25 by, oops, sorry about that, by x. Okay, and lastly, obviously, they'll have the kids area, which is 7 by x. Let me do a different color for that. Let me use blue. 7 by x. Okay, that makes sense. And then question C, hopefully you got this. You can think about the total area of the surface as the area of the large rectangle. You can multiply the length and width of the whole pool. Okay, and that's what they did here. Let me take this out. Okay, let's find out more about that question. The expressions that you wrote to represent the area of the water surface of the pool are equivalent expressions. All of those are equivalent. Each expression shows a different way of looking at the situation. We showed you 3 of them. If you don't remember them, I would go back in this video. You can use properties of operations to show that the expressions are equivalent. And another way to test whether the 2 or more expressions are equivalent is to evaluate them for a specific value of variables. Remember to always check your work with expressions by plugging in a student-friendly number. I would plug in either 2, 5, or 10 most of the time. In this case, they plugged in 10. As you can see, for example, you could evaluate each expression for x equals 10. So you're just checking your work by putting x equals 10. So let's look at the first one. Remember, the first one was 8 plus x times 25 plus, because you're going to add both rectangles, 8 plus x times 7. And when you do that out, well, first of all, you need to plug in 10. As you can see, they did that here. Okay? 10 plus 8 is 18, and then times 25. 10 plus 8 is 18 times 7. 25 times 18 is 450. 7 times 18 is 126. When you add it together, you get 576. The second question, they did 25 times 8 plus 7 times 8 plus the 25x plus 7x. Remember, x in this case is 10. So look, they rewrote this expression, but they plugged in 10 instead of x. And when they do that out, they should come up with the same answer. Well, let's see. 25 times 8 is 200. 7 times 8 is 56. Remember, multiplication comes before addition in order of operations. 25 times 10 is 250, and then 7 times 10 is 70. When you add them all up, again, you get 576. And then the last one we just did, 25 plus 7 times 8 plus x. That's the whole pool. Okay, the whole pool. 25 plus 7 times 8 plus x. Correct? And when you, whoops, sorry about that. And when you do that out, 25 plus 7 is 32. Remember, it's 8 plus 10, not 8 plus x, because again, we plugged in x equals 10. We're just trying that out. And then when you do the math, 8 plus 10 is 18. 32 times 18 will give you 576. So all three expressions would work. Okay, they're all equivalent. No matter which expression you use to find the total area of the surface of the pool, you get 576 square meters as your answer. The three expressions are equivalent. If you choose a different value for x, the three expressions will have a different value, but they will all be equal. You should try that if you want to.